This is another problem of combined gas law, and let me read the problem first and then we'll write down the data. At 25 degrees Celsius, the pressure in a 5.50 liter cylinder is 5.05 atmosphere containing 8 moles of gas. What will be the new pressure if gas is added to give a total moles of 10.2 moles at a new temperature of 33 degrees Celsius and the volume is compressed to 4 liters. Okay, so let's go ahead and write down our data now. Once we know all of what the problem is asking for, it's asking for a new pressure. Okay, so we need to write down the ones and the twos. Okay, so at 25 degrees Celsius, which means T1 is 25 degrees Celsius, the pressure P1 in a 5.50 liter, which means that the volume is V1 is 5.50 liters, and the pressure is 5.05 atmosphere containing moles, which is N1 is equal to 8.00 moles of gas. What will be the new pressure? So what will be the new pressure if gas is added to give a total moles? So N2 is 10.2 moles at a temperature of, so T2 now is 33 degrees Celsius and the volume is compressed to 4.00 liters. Okay, so those are our numbers for everything. In this case, since all the numbers are changing, we need to use the entire combined gas law. P1, V1 is equal to N1, T1 is equal to P2, V2 over N2, T2. Okay, and first of all, let's go ahead and convert our temperature to Kelvin, to 73 Kelvin here. So this one is again 298 Kelvin, and the other one is going to be 306 Kelvin. Okay, we are calculating for pressure 2, the second pressure, okay, which is over here. So let's go ahead and write that out. P2 is equal to P1 V1, and then we bring the N2 T2 up there, and then we have N1 T1 down here already, so N1 T1 and then V2, okay, comes down here. So that is our setup. So again, we're calculating for pressure, okay, new pressure, and all the other numbers are known to us. So let's go ahead and plug in all the numbers. So pressure 1 is equal to 5.05 atmosphere. Volume 1 is 5.50 liters. The first number of moles, the final moles that we have in there is 10.2 moles, and the final temperature that we have is 306 Kelvin, all divided by V2, which is the new volume, so that's 4.00 liters, times N1, that was the initial moles, 8.00 moles, times, and then T1, this is the initial temperature, 298 Kelvin. Okay, so cross out the units and we are left with atmosphere, which is what we need. And once you do the calculation, your answer should come out to be 9.09 atmosphere. The thing about combined gas law is that since so many numbers are changing, you really cannot predict what the new numbers are going to be. Okay, because if we had just Boyle's law and Charles' law, then there's a direct relationship. But if you change the number of moles and the volume and the temperature, then sometimes it's really hard to predict, okay, what the new value is going to be, because you know you have reverse, inverse and direct relationships going on. So for those kind of things, this kind of combined gas law is really very useful. Okay, so that was this problem. Now we're going to go on to ideal gas law. Ideal gas law, as we know, is PV is equal to nRT, and where R is the gas constant. Okay, so these problems are actually quite straightforward. Not so much about initial and final, it's just about getting the right units, because the gas constant has very specific units, okay, for us, and Usually this is going to be 0.0821 liters atmosphere mole divided by mole Kelvin, which means that when we start working with ideal gas law, we have to bring all the units to liters and atmospheres and moles and Kelvin. Kelvin we are used to, but we have to work on atmospheres also, okay, at this point. So here is the problem. What is the volume of 5.12 moles of an ideal gas at 32 degrees Celsius and 1 atmosphere? Okay, so N is equal to 5.12, temperature is equal to 32 degrees Celsius plus 273. Do that right away so that we don't have any issues. And that is that Kelvin there. And then our pressure is 1.00 atmosphere, which is perfect because that's what we need for the gas constant. Okay, and we are asked for the volume. All right, so PV is equal to nRT. We're calculating for volume, so that's nRT over P. Okay, cross multiplication works really great. And so then our N is 5.12 moles. R is 0.0821 liters atmosphere, remember, divided by mole Kelvin. And then our temperature is 305 Kelvin and divided by the pressure, and the pressure is 1.00 atmosphere. Okay, go ahead and cross out the units first. So moles, moles, Kelvin, Kelvin, and then atmosphere, atmosphere, all gone. So we're left with liters over here, which is perfect because that's what we need. And so once you do all this calculation, we should come out with 128 liters, which if you want to bring that down to two significant figures, which is 32 degrees Celsius, that was two significant figures, then this will be 130 liters. That's a final answer. So actually ideal gas law is very easy to work with. Just plug in the right numbers at the right place.